Hi, my name is Aaron here. I'm the instructor for CCNA training. Can everyone hear me?
Yeah, we can hear.
Right. Is there anyone finding difficulty in hearing or seeing my screen? Please let me know quickly so that we'll start.
No, it's fine.
So if anyone has any problem, please type in so that I can see the message.
Okay.
All right. So I take it as no problem. So no one has no problem in hearing me and also in seeing my screen. That's nice. Thank you. So whenever you want to talk to me, you just turn on your mic and you can talk. The rest of the time keep it mute so that there won't be a loop in hearing. Right. First of all, let me welcome you to this new version of CCNA. It's nice to talk to you and it's a privilege actually. So the CCNA, as we discussed, that we are going to learn is 200, 120. I hope I gave you this number on the introduction day. And about CCNA, we're going to spend more than a month's time from now on learning CCNA. Much detail, we'll go really deep. We don't have time limitation. Until you master, we will be doing the subject. Now CCNA, as you all know, Cisco Certified Network Associate. When I did CCNA, I was thinking like, when I thought of doing CCNA in 2005, I thought that CCNA stands for Cisco Certified Network Administrator, something like that. But later I understood it as Associate. Associate is the entry level. Cisco Certified Network Associate. Now, this is the hierarchy, this is the level, this is the step that which we will be following as we learn Cisco curriculum. So this is your entry level, associate level, where you can take the CCNA in two different exam or one single composite exam. But we are learning to write the exam in one single composite exam, CCNA. We don't do ICE ND1 and ICE ND2 separate. We do together. Now, once you finish your CCNA, you are eligible to appear for CCNP, Cisco Certified Network Professional. So the prerequisite for CCNP is CCNA. For any CCNP, regardless of topic like routing and switching or wireless or security. So CCNA is the foundational certification. Once you finish CCNA, you can get into CCNP professional level, and once you're NP, you are eligible to appear for CCIE. But for doing CCIE, seriously, this too is not mandatory. Certification is not mandatory, but understanding of CCN and NP, the subject knowledge is very important before you get into CCIE. You can write CCIE directly without having CCNA and NP certificates. But in order to write CCNP, you need a CCNA certificate. So CCIE can be written directly at any point of time. There is no limitation. According to norms, it says you need to have 2 years of experience, but the reality is, in practice, no one follows that. Anyone can write CCIE. I have my student, CCIE certified student, in the age of 21 and 20s. So without writing CCNA and NP, you can have CCIE, but you need to have a very good knowledge on this too. Right. So this number 64802 is the old number, so do not see this. Now, if you take Cisco certificates, there are a lot of Cisco certificates. One is routing and switching. Another one is design. Another one is service provider. Another one is security, voice, storage, All right. One more is missing. My favorite, data center. It's missing. Right. There are many Cisco certification, many divisions in Cisco certification. Now, if you want to go in any division, if you say, I want to go into voice, for you, you must do the basic CCNA that we are learning. Any branch you take, you have to have the CCNA that we are learning now, the CCNA 200, 120. Without having 200, 120, you cannot do any other CCNAs. If you want to do CCNA security, you need CCNA routing and switching. That's the basic prerequisite for any other CCNAs. So, the certification that you are learning now is really very important. And the CCNA that you learn is very important than CCNP and IE. The reason why I say that, CCNA provides you the foundation. If your foundation is good, your professional level and your expert level will be good. You will easily grasp things as you go higher. If your CCNA is not good, you cannot go higher successfully. CCNA is very important according to me than your CCIE, than your CCNP. So you are enrolled for a very important course. In networking, if you really want to shine, you have to explore the CCNA as much as possible. Right. I'm there to help you in all levels to understand the entire subject. Right. So we don't deal with wireless. Oh. Fine. What are the topics, the overall topics that we are going to have on in CCNA? Now we are having now introduction. Currently we are undergoing introduction to networking. We are having introduction to CCNA. Next will be like learning what is TCP/IP model, what is OSI model, and the difference between various network devices, how the Cisco router routes the traffic, how the commands look like, how the interface look like, and what is really routing means, and what are the protocol that contributes a successful routing. Apart from 3 protocol, we also learn static route and default route. These are all the building blocks of routing. And after, we will be getting inside switching. Switching is also very, very important for associate level engineers, for L1 engineers. Switching is very important. People avoid switching. They concentrate more on routing, but they don't do much concentration on switching. So when they appear for an interview, they face a lot of trouble there. Switching is very important. So we will be also learning switching, how a LAN can be designed. When you design a LAN, what all things that we need to keep in mind, and how the switching happens. And there are a lot of switching protocols like VTP, VLAN trunking protocol, STP, spanning tree protocol, and then inter-VLAN routing means communication between 2 different VLANs, wireless LAN. So these are all the area which we will be covering under switching. And then we will also see WAN technologies. We will see first what is WAN, and then what are all the protocol that works on WAN, encapsulation protocols like HDLC, point-to-point protocol, frame relay. Those things will be covered on WAN technology. And under network services, we'll be learning network security. Means how can I control the access? I cannot allow everyone in the internet to get inside my network. Then how I'm going to allow only those whom I want to allow? By writing an access list. So it's partially a firewall. You can make a switch as a security box, firewall box. How? By writing an ACL. ACL is nothing but set of permit and deny statements, allow and block. So that makes your router to be a firewall. So those things we'll be going in depth. And we'll also learn some IP addressing services like DHCP, what is Dynamic Host Configuration Protocol, and what it does and how to configure, and so on. NATing. In NATing we have three different types of NAT: static NAT, dynamic NAT, and NAT overload. NAT overload is also called as PATI, port address translation. Once we finish this, we will see advanced technology on WAN and IPv6. We'll do more focus on IPv6. We'll go beyond the syllabus. The reason is IPv6 is very important for you to clear today's interview. IPv6 is being implemented everywhere today. But you cannot expect IPv6 tomorrow. But it will take, a reasonable time, around we can say 10 years down the line, to see only IPv6 all around the world. But IPv6 is very important. We'll be going very deep into IPv6. So, and then various network technologies we will discuss, right? Now, if I'll ask what is networking, how we will define? Can anyone turn on your mic and explain what networking is according to your view? Just tell your name and explain what is networking according to your understanding.
Hi, this is Sanjeev Reddy.
Hi, Sanjeev.
Yeah,
Yes.
connecting the various devices is network.
Connection of various devices. Very nice. Can anyone else say what is that various device mean? Anyone else? Not Sanjeev Reddy, anyone else?
Yeah, this may be the telephones or the computers, any kind of.
Okay, what's your name?
device.
Name first. What's your name?
Sorry. Yeah, Mohan.
What is your name?
Mohan.
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 Okay.
Yeah.
Mohan, tell me, what does that various device mean here?
Yeah, this may be telephones or this may be any computers or anything else.
Okay. It can be computers, it can be telephones, means IP telephone, right? IP telephone.
Yeah.
Anything else? Others also can talk if you have
Yes, we will.
something to say about this. Thanks, Mohan. Anyone else? What is networking? Sanjeev Reddy said it's connection of devices. Mohan said devices means not only just computers, they are also IP telephones. Is there anyone want to add something more to this? You can give your name and then, yeah, name first.
Yeah, hi, this is Raj.
Sorry, Raj, eh?
Yeah,
Hi, Raj.
yeah,
Tell me, what do you want to add to this?
yeah. Networking is basically linking two or more computer devices to share data and
Mhm.
get information.
Very good. Now, Raj has added one more function of networking. Now, why do you connect in first place the PCs and phones? For the sake of communication. All right. So, network is nothing but devices connected together, devices like telephone, IP telephone, computers, for what purpose? For communication. Anything else, Raj?
Uh,
All right. Any other person want to try something? Sanjeev Reddy has said it is connection of devices. Mohan said devices like PCs and IP phone, telephones. And Raj said, why do we connect? We connect for communication. That's very nice. Is it only communication? Do you just talk over IP phone? Don't you do any other thing? Or you just talk over PCs? Don't you do any other thing?
Yeah, we share files.
What's the name?
Mohan.
Mohan again? Okay. So Mohan says not only communication, we also send and receive files. So sharing of information, file sharing. Very nice.
Yeah.
File sharing. Right. Anyone else? Hello? Turn on your mic and then speak. Give your name first and then speak. No one? Hello? No one? Okay. So Sanjeev Reddy said it's a connection of devices, and Mohan added to it devices like PCs and IP phones, and Raj said we connect this for communication, and again Mohan added something more to it. Not only we communicate, we also share files. Now, only files you share? Only files you share or anything else? Do we share printers in the network? Yes, we do share printers in network. Yeah, we share printers in network. What else we share? Hard disk. You know, data centers, what they share? They share their hard disk. They share their hard disk, a huge hard disk in the cloud. Today, cloud computing is possible by sharing, because of sharing of resource, such as hard disk. Processor. Processing is possible because of sharing of processor. Right. So networking is not simply connecting two or more devices together. It is more than that. We put together devices like printers, scanners, PCs, laptops, IP phones, and many more. Even nowadays, human beings are traced in networking. You know, human beings carry IP address. Human beings are injected with a chip in countries, grown-up countries like USA, where you live. Army people are chipped, and they are tracked wherever they go. Vehicles are being tracked. So networking is not just putting devices together. It's more than that. Right. So we see networking in schools, we see in colleges, we see in research centers. Everywhere you see networking. And networking, for networking there are a lot of things contributes. Like this: wireless antennas, wireless IP phones, PCs, a data center, IP phones, IP television, right? And the console where you control the devices, and networking, ISPs. There are a lot of contribution done to networking from various technologies. Now, a human being, we use network for watching movie, getting knowledge from the internet like Wikipedia, Google, so on, to share our day-to-day videos and photos, to share messages. Networking is used really, in a very big level. Today, things gets communicated very faster through social medias like Facebook and YouTube. These are all possible because of network. So in networking, you have various types of traffics. Not just we send files, we also send voice. Now you are hearing me. What is that? Voice over IP. Voice. That's a kind of traffic that goes in the network. Video conferencing, same thing we are doing now. So not just data goes inside the wire as a traffic, voice, video. People even shop You know, we do a lot of purchase through eBay, Amazon. What is that? That is also a kind of network traffic. We surf net, browsing. That is also a kind of traffic. We pay bill online, a lot of bills, telephone bills, electric bill. Those are all also traffics, various type of traffics we do see in networking. Not just simply the documents we share. We share emails, we share printers, we share our database, we share movies, and many more. Now, all this go in a common channel, wire, like Ethernet, fiber optics, Wi-Fi, with proper convergence, which is taken care by quality of service. So, that is what our next topic is also. See, the quality of service. What is quality of service mean really? Quality of service. Though it is a hard topic and which is really explained much more in detail on CCIE level, but still, you know, I want to explain you here what is quality of service. How can I understand quality of service easily? You see, quality of service is nothing but queuing of service. I'm sorry. One second. Okay. Quality of service is nothing but queuing of service. Now, whoever stands on the first in the queue will be served first. That is what quality of service. If you want voice traffic and video traffic to be prioritized, put them in the front row. Put them as a first packet in the queue so that voice and video will be without any jitter. See, this is what jitter means. Without QoS, the picture will be jitter, blurred. With QoS, pictures will be very clear. Why? Voice and video traffic has to be prioritized, has to be queued first, has to be sent first. Same like even Messenger. You use Messenger in Facebook, Gmail, Google Hangout. All this Messenger are time sensitive. It has to be delivered at once. So it has to be put in the queue, in the front of the queue. So quality of service is nothing but queuing of service. So in networking, we not only simply route packet, we also provide quality of service, queuing of service. We say this packet goes first and this packet follows next, so that on the receiving side, there will be a quality maintained. So networking is really big. It is not simply putting devices together and start communicating. It's more than that. We are going to learn step by step a lot of things. Quality of service comes in CCIE level, though we may not be learning quality of service in CCNA, but it's really an interesting stuff. Quality of service, as for now in CCNA what we learn, quality of service is nothing but queuing of service. So that is one job what a network administrator will do. See, here is another job, security. As a network engineers, what all you are going to do, you may be providing quality of service, or you may be securing your network. From whom? From the black hat guys, from the bad guys. Not everyone in the network is holy man. There are a lot of bad guys, black hat guys. Black hat means attackers. Black hat, bad guy, who is always trying, who is always notorious, trying to do something bad to someone's network. Those people are called as black hat guys. Black hat. Black hat. They are very seriously very bad guys, bad attackers. Their only motto is to destroy the network. They are not really, always looking for stealing some data. Not always. Sometimes they also do that, but most of the time, if you see, they try to bombard some network, make some chaos over there. That's what the main aim of the black hat guys. So we have to protect our network from those people. For that also we need to learn networking. That's why we are here. So not just providing quality of service, we also protect our network from the enemies. So if you see networking, there are a lot of protocols involved in it. In order to see the web pages, we need HTTP. In order to transfer file, we need FTP. In order to send and receive mails, we need SMTP and POP3. In order to remotely log in, see if you want me to troubleshoot from India, the router in US, what I need to do is I need to know how to telnet. So telnet is another protocol in a network. So like this, there are various protocols in network. Network is not simply connecting to device and communicating. See, we have a lot of other business to do. We want to view some pages, we want to share some files, we want to send and receive day-to-day mails, we want to remotely take someone's PC and control them or troubleshoot them. For all this, you need protocol support. So we have a lot of protocols, and all this protocol run in every PC, every router, every network device. Right. So what are the network devices we have? We have a lot of devices. We are going to go in depth on all these devices in some time. Once this chapter is over, I will be taking you to this topic called network device. We have various devices like repeater, which is nothing but regenerator. Hub, which is bridge, switch. These are all layer 2 devices. Router, layer 3 device. What I point out OSI layer. Don't worry if you don't know OSI layer. We will be learning what OSI layer is in coming classes. Now, router is a layer 3 device, routing device. Switch and bridge is a switching device. They worry about MAC address. NIC, network interface card. NIC, network interface card. It is there in every PC. Network interface card is there in every PC. Every switch, every router has got something called NIC, network interface card, where you connect your Ethernet wire to your laptop. That's called NIC, network interface card. We got modems, right? So various network devices we will be discussing in depth in some time. So how do you connect devices? We connect wirelessly, we connect with a cable. Even if you take cable, there are various types of cables. Straight through, crossover, serial, fiber optics, various types of cables we have. Even in wireless, we have different technology. IEEE 802.11a, 11b, 11g, 11n, Bluetooth. Likewise, there are various types of wireless technologies. So connectivity is either through physical media or also through wireless. Right. To understand these things, we need to learn networking properly. That's why we are here. Now, what are the elements of network? If you take network, there should be a sender, there should be a receiver, there should be a medium or media, and there should be a message. These are all the elements of networking. You need to have a source, you need to have a destination. Source, destination. Now, we are not the only source and destination. There are many source and destination connected to this network. So we should follow some rules so that everyone will be served. So We need source, we need destination, we need rules. What is that rule called? Protocol. Rules in networking we call it as protocol. Protocol. We have a lot of rules. If you want to see a web page, this is the rule, HTTP. If you want to transfer a file, this is the rule. What is that? FTP. So, the main four elements of networks are the protocols, the medium means wireless or wired or what type of cable, fiber optics or Ethernet or Wi-Fi or Bluetooth. That's what medium means. And the message which you are sending from source to destination, and the devices, source and destination device involved in it. So four elements of networks are rules, also called as protocols, medium, also called as interface, like Wi-Fi, wireless interface, or cable interface like Ethernet, gig Ethernet, fast Ethernet, fiber optics. There are various types of mediums we have. Messages, various types of messages we have. We have video, we have audio, we have text, we have PDF, we have document. Sorry, various type of messages, and a device to send them to and fro. Now, this chapter actually, every slide, they don't have any continuation actually. This is an introduction chapter, so they try to give you everything in a nutshell here. So, if you see, there is no really an order in this PPT, but still, we have to try to understand every bolts and nuts of this PPT. So, we started with what networking is and why do we need networking and where all networking is being used, and then we started getting into some serious issues like what all network does, not just communicating, it also provides quality of service. It also provides security. The network engineers try to provide security over the network. And there are various protocols involved in networking depending on the services that we use. And there are various devices involved in networking. There are different types of connectivity we have in networking. And there are different elements in networking. So that's what we have seen so far. Is that clear so far? Shall we go to the next level? You can just turn on your mic and say yes if you want to go next level. Or if you have question up to this level, you can ask. Shall we go to the next level?
Yes.
Okay. Okay. I heard Sanjay already said yes. Okay. Raj, shall we go next? Mohan, shall we go next?
Yes.
All right. Let's
Yes.
go next. Now, all right. Thank you. What is LAN? What is local area network? What is local area network? See, if you have a group of devices connected through some LAN media, a lot of people misunderstand LAN. They say within a building it is LAN. No, not always. Not always. Within a building also you can have WAN. If you have multiple networks within the building, it is WAN. Now, what really LAN here means in networking? A small network that is connected through the media which supports small range, like token ring, supports very small range of coverage. FDDI, Ethernet, fast Ethernet. These are all LAN interfaces, LAN cables. So if you will have some LAN cables, then devices connected in a single subnet. If you have one subnet, single subnet, devices in same network, single subnet, and connected through a LAN media like Ethernet cables. We call it as LAN. It may be within the building, or it can be between two buildings also. If you have a fast Ethernet cable between two buildings, next to next, and have a single subnet, meaning one building has 10.0.0.1, the other building has 10.0.0.50. See the same subnet 10 connected through an Ethernet media. It is LAN. It can be between two buildings also. What is MAN? It's actually not really needed for us. MAN, Metropolitan Area Network, Metro Ethernet. That is within a city limit. And WAN, we need to understand LAN and WAN very well. What is WAN? Wide Area Network means what? We connect to different networks in different area, a large area. And just not single subnet, it is multiple subnets. Now you got one PC 10.0.0.1 and another PC 20.0.0.1, and you use a WAN device called router to connect between two different networks. Then it is WAN. Whereas here you don't have a router, you have a normal switch, a LAN device, a WAN device. We will be dealing with devices in some time. So in WAN, if you see, we will have a lot of encapsulation protocols. We'll be using any one of this. Frame relay, F means frame relay, ISDN type of connection, X.25, very old one, analog dial-up, very old one, ATM, very old. PPP, it is missing here, point-to-point protocol, that is also a WAN protocol. So LAN is a small segment of network connected through a LAN device, switch. This is another LAN because you connect all these devices through a switch. So connecting between two different LAN, you need a WAN device. See the cable, this is not an Ethernet cable, this is a serial cable. If someone draws like this, it means serial. If someone draws a straight line, then it is Ethernet, LAN cable. These are all LAN cables. This is WAN cable, serial cable. And this is a WAN device called router. And this is a LAN device called switch. So you may have here network like 10.0.0.0 network. Here you may have 20.0.0.0 network. Here in between you may have 30.0.0.0 network. Different networks mean WAN. Same network, LAN. So LAN and WAN is not restricted to a building or an area. You need to have something like this. If you have multiple networks connected via WAN device, then it is WAN. Router is a WAN device. This is a router. Router we draw like this. Switch we draw like this. Right. So that's for WAN and LAN. What is internet? Collection of many networks. That's why it is called as internet. Collection of many networks. So this is one LAN, this is another LAN, this is another LAN, another LAN. All LANs are connected through a WAN device called router. These are all routers. Routers. Without routers, you don't have internet. Why? Only the router can communicate between multiple networks, different networks. Internet is nothing but a collection of networks. LAN, a single segment. WAN, this is what WAN. Internet is what WAN. Right. So if you take internet, it is connected like this. It is connected like this. One ISP is connected to another ISP, another ISP is connected to another ISP. Now I am sitting in India, I am talking to you, you are sitting somewhere in US, and you are listening to me. Do you think only one ISP is there in between? No. ISP also has a big LAN. This is one LAN, this is another LAN. All LANs put together forms an internet. Right? There are different tier approach. The core ISP is called as tier 1. And we are all connected to tier 2 and tier 3. Right? So 3-tier approach we got. Tier 1 is the core internet. Tier 2 is the main ISP. And tier 3 is the local ISP. Okay, so internet is nothing but networks of networks, collection of networks. That's what internet is, networks of networks. Now about this, you are very well aware of what it is. There are various types of network topologies we have. We have bus topology. This is how connected. Star topology, we are connecting through switch. Ring topology, which is no more. We don't connect ring topology physically, but logically we may have some time. Star topology, hybrid topology, extended star topology. Now, why do we learn all this in our colleges? In order to understand the logical part of the data flow. Physical topology is not our focus. We try to understand the flow of data, the logical flow of data through physical topology. As you keep attending this class, you will understand what I really mean here. So why we learn in our colleges star topology? Do you think we are going to arrange PCs in this manner? No, we are not going to arrange PCs like this, stylish way. No, it's not like that. We are not learning this topology, physical topology, to design computers in a room in a star fashion or in a bus fashion or a ring fashion. We learn this so that we can understand the flow of data. How it flows. Is it flowing like a bus, or is it flowing like a ring fashion, or it flows like a star fashion? How it flows. So in order to understand the logical flow, we learn this physical topology. Logical topology is nothing but the way that the communication happens across the physical topology. The fashion through which the traffic flows is what the logical topology means. Right, these are all the symbols that is used in our Cisco curriculum. Router means it will be like this. It is drawn like this. So in our day-to-day class, if I draw like this, what I mean is router. Sometimes I'll draw like this, RA. So that's the name of this router. And if I draw like this, and if I write SW, it is switch. So router is connected to a switch. Right? So servers are like this. Hub is picturally represented like this. Desktop, laptop, firewall. So on a router, if I put like this, then it's a firewall. Brick. Sorry. So when I have an ACL over it, access control list, what I have is a firewall. I have set of permit and deny statement. IP phones, not normal analog phones, IP phones, the phones that work using IP address. Wireless access point, which you already have, which every one of us have in our house. Wireless access point. You may be having a Cisco wireless access point, or 3Com, or there are various vendors actually. I have an access point called Apple Talk Airport Capsule. Sorry, Apple Mac. It's It's from Mac, airport capsule. So this is the symbol that Cisco gives for wireless access point. This is the symbol for wireless router. This is the symbol for serial cable or WAN cable. And this is the straight line for LAN cable. And this is Wi-Fi. This means Wi-Fi. Right? So various symbols that we should know. So don't worry, you might have seen a lot of new things so far, but one good news is you will be shared with this PPT. You will be getting this PPT after this class gets over. Mr. Satish will be forwarding you all this PPT. Daily PPTs will be shared with you. Also the video, as you all requested already, for the hands-on, for the practical, the videos will be recorded and it will be given to you, and the tools will be shared so that you can also run the video, pass the video, forward the video, learn by writing down in a notebook, and you can do also practical at home by yourself. Also under the supervisor, I will also supervise when you do the lab sometime. So don't worry if you have not taken notes so far. Material will be shared to you. Next, how the communication happens. See, this slide really explains the communication in a very simple manner. You cannot put it in more simplest form. Someone is sending some data to someone. So this is a source, this is the destination. Or this handsome guy tries to talk to this beautiful girl over the IP phone. So he's a source and she's the destination. Now how the data is transferred, whether a voice data or a normal data, how it is actually shared. See, the source sends the message, it is encoded. There's an encoder who is encoding the traffic. Why someone should encode it? The encoding is needed because network will not understand your voice. Network don't understand your English data. So someone should encode it, someone should translate it so that the network media can understand it. That's where encoding comes into picture. Someone takes your voice, someone takes your data and encodes it, presents it in the network understandable language, which we call it as encoder. And then it is being transmitted over the media. It can be physical media, or it can be a wireless media. So on the receiving side, the receiver receives the signal, decodes it, and understands the message. Hello? 15 minutes until it. Right. Right. So there is an encoding and there is a decoding process. On the receiving side, decoding happens. On this. Hello?
Aaron use screen వస్తుందేదో అదే లింక్ ఓపెన్ చేసినా.
I'm sorry, I'm not hearing you. What is that you say?
నాకు అదేం రాలేదు, నాకు ఒకటే మెయిల్ ఉంది Ccna.
Hello? Who is it?
నాకు మెయిల్ పంపలేదు.
What do you want? Or I don't understand. I think someone is talking to someone else. Right. So the message is sent from the source. It is translated so that network will understand it and transmitted in a transmission medium. The receiver receives the signal, decodes it back to the English language or the voice. So who encodes here? This gentleman encodes. Who decodes here? This lady decodes. Likewise, this PC encodes and this guy decodes it, the destination, decodes it. This is how the communication happens, the step-by-step process of communication. Right? This happens everywhere.